My apologies. I'll have to send 2 videos today. I just got a phone call from Jill and it cut me off. So my son Vince had to show me to put my phone on Do Not Disturb, and I'll have to call Jill back. Okay, so we were talking about oranges and your examples yesterday and how good they were. The next apple is a Gala, which is a medium-sized apple. It's about the size of your fist. The largest apples are as big as grapefruits. The smallest are the size of cherries. This Gala is cut into 5 equal pieces. Each piece is 1/5. 1/5 plus 4/5 equals 5/5 or 1 whole. When the numbers above and below the line are the same, the fraction equals 1 whole. And then they show us a picture of these little elves again. I put the dogs outside so they wouldn't be barking and disturbing us. Apple blossom. Apple trees grow flowers in the spring. Bees fly from flower to flower and spread pollen on the apple blossoms. This is the best start of an apple. Thank you, bees. Without the bees, there would be no apples. 1/6 of the bees are busy working. 5/6 of the bees are looking for another apple tree, or maybe even a pear tree, a plum tree, or a cherry tree. Here's our little buzzy bee friends. Mrs. McKinney knows lots about bees and honey. She and her husband make honey. Cortland. If you cut an apple sideways, you will notice that the core is shaped like a star. Did you ever do that? Dividing the apple sideways instead of from top to bottom will not give you equal parts. The top, the middle, and the bottom of an apple are each a different width. And we talked about that in class, how when you divide a shape into equal parts, that means you should be able to lay one part on top of the other and it would completely symmetrically cover that part. This way, these are not equal pieces. So we couldn't say that this is 1/8 of the apple because it might be smaller than this larger inside piece. There are 3 basic types of apples: eating apples, juice apples, and baking apples. No matter how you slice it, a Cortland is a wonderful apple to use when baking a pie. And you see they show 6/7. Asian pear. Sometimes looks can fool you. This fruit looks like an apple and it's shaped like an apple, but it tastes like a pear. Why, you ask? It is a pear. Let's use this Asian pear to learn about improper fractions. Okay, and we're going to talk about that too in a minute. If this pear is divided into 8 equal pieces, each piece is 1/8 of the pear. A whole pear is 8/8. Imagine you have 9/8. 9/8 is an improper fraction. You would have to use 2 pairs to make 9/8. 9/8 is really 1 whole pear and 1/8 of a second pear. And this showed up on our morning math. They would show 2 boxes and they would both be shaded, but they would only be divided into fourths. So you guys were to write 8/4. So these are improper fractions, which is something a student asked a question about, and we're going to talk about that too. The book's almost done. What is the difference between cider and apple juice? Cider is squeezed from fresh apples. The liquid is tan and full of pulp. 1/9. Apple juice is a cider that has been filtered. The tan pulp is removed and the apple juice is clear. Are you thirsty? Would you like 1/4, 1/2, 3/4, or 1 whole glass of apple juice? And here's the difference. You can see 1/4, 1/2, 3/4, and 1 whole. Here are 10 apples. Oh well, there were 10 apples. Here are 9 apples. One has been eaten. 1/10 is now a core. 9/10 are whole apples. You guys had some great examples yesterday of fractions that are divided different foods. Good job. The millions of tons of apples harvested every year are still picked by hand. Out of every 10 apples, 6 are eaten fresh. 2 out of every 10 are squeezed. The remaining 2 are made into canned apples for pie filling, jams, jellies, and apple butter. Delish. While you were reading this book, someone baked an apple pie. Let's eat a fraction of it. And that's the end. And then on the back, they show you some examples. And I have written a couple of things in a notebook from my foreign exchange student from Costa Rica sent this to me, and it's made out of banana paper. Thought that was really cool. So it's actually made from bananas. And it goes right along with our fruit theme. So I'm going to show you a fraction. Okay. This fraction is 1/8. We talked about this in the book, and we talked about this enough in class where I'm pretty confident you guys know that 1, the top number is the numerator. 8, the bottom number is the denominator. 1/8. In my example, I have an apple. Don't look at the banana yet. I have an apple that is cut into 8 slices. If I eat one, I have eaten 1/8 of the apple. Sorry. I'm going to show you another fraction. Following me? Let's turn our plate around. Okay. 1/4. I used a banana. This time, instead of writing numerator and denominator, on top I put 1 is the worth of each piece. It's cut into 4. So 1 is the worth of each piece. And how many total pieces are there? 4. So the numerator is 1. Each is worth 1/4. The denominator is 4. There's 4 total pieces. If I eat one, how much of this will I be eating? Okay, that's a question for your Google Classroom. How much of this banana did Mrs. Leone eat? So good. I'm not going to tell you how much I ate. You have to send that to me. Okay, some more examples. Let's turn it, this way. Oh, there we go. I cut a green apple in half. Granny Smith, remember? Green apple in half. And I want you to look at the fraction and tell me, what word do we call the number that's on the top of the fraction bar? And what word do we call the number that's on the bottom? Do you have it? You don't have to answer this in your Google Classroom. You could just say it out loud, because I'm going to tell you that the top number is the numerator. The bottom number is the denominator. Okay. One more. You guys are doing great. Last one. 1 whole. I didn't cut this at all. I left this little clementine whole. And you notice the 1 over the 1 Anything that has the same number on the top and the bottom equals 1 whole. Last thing we're going to talk about today. Thank you for watching this. I made one more slide. I'm going to set it up here and tape it. Actually, let's put it here. This slide says 12/8. If you remember in the book, and we talked about this when we were together in school, 12/8 is an improper fraction because the bigger number is on top. If something has eighths, if we're talking about eighths, these two shapes both had 8 pieces. I shaded this whole one in. I shaded each of the 8 pieces, so 8/8 are shaded. But my fraction is telling me 12/8 should be shaded. I have 16/8 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16/8. I have shaded 8/8. How many more eighths do I have to shade for this to equal 12/8? Stop and think for a minute. Take a think minute. Well, I already have 1, 2, 3, 4, 5, 6, 7, 8 shaded. How many more do I have to shade for it to equal 12/8? Well, that would give me 9/8. Am I there yet? Not quite. 10/8? It says 12. 11? 12/8. That is an improper fraction. Here's a challenge for you on this fun Sunday.